Hello, we are actually waiting to see you in February. If you don't know, I'm Dr. Nicole Turner-Lee. I am the chairwoman for TPRC, this great organization that brings research, policy making, as well as civil society organizations and academics together to really think about how do we solve the pressing issues in technology. Today, I'm actually happy to taking on moderator privilege in this case to have this conversation around facial recognition technology. And this is a really important conversation for a couple of reasons. Primarily, it's important because we actually have seen that in the course of events from the pandemic to now what some are calling the new pandemic of racism, which I don't quite understand that because it's kind of been around for a while, that we're actually seeing this ban on facial recognition technology across the board. Companies are now realizing just how important it is to really go back and reset as we look at these technologies. In addition to that, we're also seeing, I think, this leaning towards understanding the role of policing and law enforcement's use of these technologies, from everything from identifying defendants to protest surveillance. I'm hoping today that we have a conversation around these areas in ways that we as researchers at TPRC and policymakers at TPRC can try to make sense of this, right? This is one of those spaces that I think, given the nature and the timeliness of the conversation, we actually might be able to do something about it. So I'm happy to be joined today by three folks that I'm happy to call friends in some way or form. I don't know who's to my left or who's to my right, so I'm just gonna shout out your name and just wave. First and foremost, we've got Nashley Cephas, who is at Amazon. I know she's got a new role, but she is one of the scientists there who has worked on this technology as well as other technologies. Hey, Nashley, how are you?
Hey, everybody, how's it going?
We've got my friend Faye Cobb-Payton, who is a person that we know from North Carolina State, who is in the business of computer science and computational science. She gets this, and she's been working on this for a really long time. Hey, Faye, how you doing?
All right, how is everyone?
And my colleague, who some of you may know, and I swear he's got the baddest setup than most of us in terms of his backdrop, and that is Dr. Rashawn Ray. And actually, I'm very happy to be surrounded by three doctors, but Dr. Rashawn Ray, who comes from the Brookings Institution, who also manages a center at the University of Maryland. And by way of heart, he is a sociologist. Hey there, Dr. Rashawn, how you doing?
Thank you, Dr. Turner-Lee. It's a pleasure to be with you and others. I look forward to this important conversation.
So let's just dive into it. And for those of you who are listening, we hope to have some time left at the end for Q&A. Nashley, I'm going to start with you because you are one of those folks who, as a computer scientist, have actually built these models. I know at Amazon as well as at other companies. And I would love to talk to you for a minute about artificial intelligence generally and facial recognition, right? AI has become more of a general purpose technology. And I think we're seeing it deployed in so many ways, from commerce to education to employment, that we're sort of taking this as something that is pretty much diffused through everything that we actually access. When we think about facial recognition technologies, I want us to do some level setting first and foremost, because I think there's often sort of this confounding of facial recognition versus face detection. So if you could actually walk us through the science of facial recognition, distinguishing between things that some of us on this call may not really realize is not necessarily facial recognition, might be more detection, that would be great. And I think we can level set that conversation and then just open it up to our other colleagues.
Right. So a lot of people, a lot of people think face recognition is, anything involving faces, but it's actually several different types of the technology. And so one thing we like to do is we like to educate people on how the technology works, especially the key stakeholders that may not always be technical, right? And so I think that the first thing is that there are ways to detect faces. We call this face detection. So that's the technology and algorithms that you train to just determine if the face is there or not. And it's important to break down the different technologies because you want to make sure that, we want to make sure we're testing and benchmarking each and every one of them, because the errors, the biases, things like that can occur at different stages within the pipeline. And you want to make sure that you're pinpointing that in terms of, producing products, designing products. That should be, a before thought, a during thought, and an afterthought in these products. And so face detection is just simply saying, hey, do you detect my face in this picture or video or not? The second one is face analysis. So assuming after you detected that there is a face here, that you want to determine, okay, different attributes about the face, Does the face appear to be smiling? What's the emotion of the face? Does it appear to be male or female in terms of binary classification? Is the person smiling? Are they wearing sunglasses? Are they wearing PPE equipment, which is a popular feature now? And so that's what we call face analysis. And there's so many different algorithms that go into just that alone. And again, each and every one of them, you want to be pinpointing and understanding, where you may be successful or where you may be failing at. And then of course, face recognition itself, there's two different types. So there's authentication. That's like when I'm using my phone and I'm just trying to understand, I have pictures of my face that the algorithm has taken me through to take pictures of my face. And now I'm trying to unlock my phone with my face. And so they call that one-to-one matching. So we're trying to understand if my face matches other examples of my face. And that could be, it could be accurate, it could be not accurate, depending on if I'm wearing makeup that day. I have so many different hairstyles, depending on what day of the week it is. And then it just may depend on the lighting. For example, if it's good lighting, I may look a lot lighter or a lot darker. And so all those things can affect it. And so the second type of face recognition, this is the last type, basically is what we call face recognition. So that's one-to-N matching or one-to-many matching, where you're trying to determine if my face is present within a database of faces. And so this can be determined, like if I'm looking for pictures of my sister in my Google Photos, and I can just point to her face and it'll try to find everything else that has her in it, even trying to create a collage or something. And then of course, in terms of face recognition with law enforcement, there are several different use cases that, may be proper or may be inappropriate, that may be used where you try to line up and see if people's faces match current data sets of other faces, such as, mug shots and things like that. So, yeah.
That to me is so interesting because I think we often sort of think of facial recognition as one technology. And so as a scientist, Nancy, I really appreciate the distinction, right? Because before we go into, what are the potential, challenges or things that we need to be looking at, we look at facial recognition in those areas where you said it's matching against a set of faces. I want to go to Dr. Cobb Payton for just a moment, because I know you also do a lot of healthcare work when it comes to AI. And I'm particularly interested for our audience, before we switch modes, to talk about, where there are cases where face detection or facial analysis can actually be helpful, right?
Right.
I know Dr. Carl Rasanik in North Carolina, in Wilmington, basically shared with me something that has blown my mind around the use of the face for the detection of chronic disease. So if you could actually just talk a little bit about that, and then I'll switch it over to Dr. Ray to start getting into some of the pernicious aspects of why we're having this conversation today.
Well, thank you, Dr. Turner-Lee. So yes, in healthcare, there are some applications that are very salient and conditions that are very salient for facial recognition in a healthcare context. I just want to give like three sort of overarching themes, one of which is to look at patient outcomes. A second is to look at patient safety. And the third is really the remote monitoring that can happen as a result of AI. Now, if you can think about this, if mom is at home and she is an Alzheimer's disease patient, or if she's prone to strokes, in those cases where those particular technologies can recognize moods and modes within a facial cue or context, when a patient may be experiencing something, then that's an exact case of when AI is of benefit. There is particularly use when it comes to comparing and using AI versus CT scans, right? And we know this, that in the case of perhaps any kind of lung cancer, breast cancer, where physicians or clinicians can't possibly look at all the data in a given time. And the aspect of a false positive or false negative has severe implications. This is particularly true when it comes to perhaps people of color, Black and brown people, women, when it comes to people that are on the spectrum, when we're talking about trans populations. So in the context of healthcare, this is where AI and facial recognition becomes really important. So prior to that, a lot of FRID was being used. A lot of wearables were being used. And in the case of loss or stolen or misplaced or crashes, those things don't particularly happen if we're actually using the face as the artifact or the condition that we are looking at in order to employ a healthcare treatment or to look at what particular symptoms may be in place for patients.
That to me is interesting because I think we need to continue to have these conversations. Technology for many of us is sort of like this either or, but in most cases, it's actually a both and, right? Because there are probably these advantages of technology as well as areas that we need to be careful of. Dr. Ray, I know you and I are actually about to embark on a project of facial recognition technology in law enforcement, and what would be the best practices, both from a legislative perspective as well as a technical research perspective that we're hearing from both nationally as well as FAE. Love to talk to you a little bit more because I know you deal with law enforcement when it comes to the introduction of new technologies. Just what does that look like when we start looking at, I think, this range of definition? Are we really calling it what it is in terms of facial recognition? Where's the breakdown in the, just give me a little background in terms of law enforcement's use of facial recognition technologies first, and then talk about what your opinion has been or observation has been in the deployment of these technologies.
Yeah, so I think for law enforcement, AI and facial recognition offers several advancements over previously used methods to deter and solve crime, to improve efficiency, to potentially save resources, particularly related to human and financial capital. These are some of the pros that people oftentimes talk about. Currently, some of the law enforcement technologies that use machine learning algorithms include everything from smart streetlights, where they can observe people, where they can not only capture their faces, but also at times their temperatures, other sorts of things that are going on, things that we see that happen in airports and have been happening at airports for quite some time. Hot spot policing is a term that people hear a lot. That's where essentially they take what used to be looking at one place that has high levels of crime and aiming to divert resources to that area. But now with other forms of technologies, they have various algorithms that tell them the likelihood of people potentially committing crime in those areas. Obviously, facial recognition, but using drone surveillance in addition to these street lights to do that. There are even some places that have been using robot police dogs. So, it's a lot of things that are happening. Geofencing, risk assessment, social media data to stop gang violence and the like. And what's interesting is in a short period of time, we went from body-worn cameras, which was 5 years ago, and even there are still some departments that are resistant to that, even though there's bipartisan support for that now. But body-worn cameras were viewed as a panacea to improve police-community relations to AI and predict actually where crime might occur. Yet the assumption seems to be that technologies using algorithms are better at identifying threats and potential criminals. In theory, maybe. In reality, some research does not necessarily support this. Similar to people, algorithms have embedded biases that mirror prejudicial decisions that occur in social life. And that's what we've heard from others as well. One central issue is that tech companies are creating AI products with little oversight and regulation. They oftentimes solicit law enforcement agencies. I know this well because my research center does this, and recruit law enforcement agencies to participate in pilot studies and trial and error in exchange for using the technology. The problem, though, is what we're seeing in places like Tampa, which is currently deploying technology that's very similar to Minority Report. They're saying these specific people are probably going to commit crime, so we're going to go ahead and pick them up. So the movie Minority Report that I think most of us know about, probably particularly us techies, is something that is coming to life now. And we also know that they're using it at airports when it comes to passports in terms of recognition software. And the United States just has a host of these things. Quickly, everything from people at protest and them using drones and other sorts of things to be able to monitor them, geofencing, like what we've seen in North Carolina, like what we're seeing with Black Lives Matter protests, where they're literally doing a geofencing and being able to scrape all of people's information from their phones to see what they're doing, to see how they're organizing. And the problem here with facial recognition is that oftentimes it gets things wrong. And I think that's the bottom line, is that overwhelmingly Black people's faces relative to white faces are misclassified, particularly Black women's faces. And in certain studies, it showed that Black women's gender was misclassified 33% of the time. Professional athletes are oftentimes confused for criminals. And the big thing is you have departments like NYPD who is manipulating blurry images to try to find out who the person is, and then using that information to arrest people and charge people and even convict people.
Wow. I mean, I'm just still hanging on to the parts of what you've talked about. And Ashley, I want to kind of come back to you because as a scientist, you know, one of the challenges that we've had with facial recognition is the fact that there are some challenges, technical challenges when it comes to people with a darker complexion. I mean, people who know me, I change my hair. This is a different hairstyle. Next week, it might be something else. You know, how do we address some of these technical deficiencies to ensure that we have more inclusive facial recognition that may help with what you just talked about, sort of that comparison with other faces, right? Because that's really where people mostly have a challenge when it's actually comparing it to other faces.
Well, look, Dr. Turner Lee, I mean, you're the expert here, so you should definitely be asking.
I'm not a scientist, though, dude. I'm not a scientist.
So when it comes to thinking about safeguards, I think there are a few things. The first overall thing is this, is that policymakers need to be able to have the legislation to get out ahead of the technology. Technology is moving so rapidly that policymakers, they can't keep up. They don't understand it readily. And so the regulation is so low that it gives people the ability to bring it in. So one of the things that I've been trying to do is to tell policymakers, here are questions that you should ask. For example, what safeguards are put in place to ensure that technology is being used properly and that it's working as intended? I think that the Facial Recognition Technology Warrant Act is a good step in this direction, which says that if law enforcement wants to use facial recognition for over 72 hours, now I have a problem with it within 72 hours, but if they want to use it over 72 hours, then they have to get a judge's approval to do so, and that will only last 30 days. So, you know, you start to see certain types of regulations in place. I think a big question that we need to be asking is, how do we know your algorithm does not have any biases? So part of what I'm getting at is that I don't necessarily think these questions should fall on law enforcement to answer. It should go to the tech companies that give law enforcement the technology to use. Because part of what happens is that law enforcement wants to use the new shiny toy like most people do, and they deploy it. And when they deploy it, it becomes problematic because now they're using it to make biased decisions. I think that racial impact statements is a big deal. This is starting to gain steam around the country, everywhere from Maryland to Oregon and Texas. These racial impact statements will say that when a legislation is being proposed, that there needs to be an assessment to figure out will there be disproportionate impacts on one racial group versus the other. And so, I mean, of course, there are other things like the Algorithmic Accountability Act, which I think is really good. The Justice and Forensics Algorithm Act of 2019 that you know very well, which requires companies to evaluate and assess their algorithms. And I think that is the way that we have to do it. We have to ensure that law enforcement can get access to new technology, but that these technologies are not used to profile or police people, because we already know, based on what we know about policing, that those disparities will fall on the bodies of Black and brown people.
Well, I like what you're talking about, and I think we're going to talk a little bit more about the legislation, but I want to just veer it over to, and Ashley, I'll go to you. I know you're muted, but I want to hear from you a little bit on the technical sort of aspect of, because what we see is that we have lawmakers that are not technical experts, right? And we have techno experts who are not necessarily policymakers, and then we got the academics like us. So talk to me a little bit about, you know, how do you address some of the technical challenges and insufficiencies that Dr. Reyes talked about?
Right. So it kind of goes back to everybody has to work together, right? We get nowhere in silos, which we've seen where we are now. This is what happens as a result of that. I think you also, it's important to have someone, I like to consider myself kind of like a free agent. I can talk the tech talk, and I can communicate to the upper level management. I meet with the policymakers and other people, other stakeholders on the team. And I'll be honest with you, not every engineer or scientist possess that skill set or ability. And so when you're talking about, you know, tech teams, and this is an industry-wide problem. You know, with all the tech companies, not just, you know, Amazon, when we're talking about, you know, what are we doing to make sure that we're filling these blind spots when you're recruiting, and when we're recruiting people, we need to make sure that we're looking and we're being very intentional about these particular skill sets that we need. More than likely, you know, if you're not changing your recruiting strategies, you're going to get the same people. You know, if you're not intentional about it, you're going to get the same things will exist, and you'll have the same sort of technologies being developed. And so being very intentional about hiring people of color, hiring diverse tech talent, hiring, even when I say diverse tech talent, I mean people that are people as well as, you know, highly skilled in technology. And those are unicorns. But, you know, if you're calling yourself a company that, you know, you pride yourself in your tech talent, you pride yourself in your workers, then you should spend the extra resources and money and whatever that takes to recruit those people. The same way the NFL recruits its top talent, you know, we can do the same thing in the tech industry. And so in terms of working on the technologies, you know, I've heard it many times, you know, oh, that our technology doesn't have biases in it. You know, we don't have that problem, don't have that issue. But you never know. You cannot assume what you haven't tested. And it really starts with that. This technology is, you know, as Dr. Ray has mentioned, Dr. Payton as well, this has been going on for years. This technology was actually, the technology we're using today was some graduate student's research 20 years ago, right? And it was in a book, it was in a publication on a shelf. Somebody came along and said, hey, I can apply this to this everyday problem. And they started monetizing it and making products. And then no one thought about, you know, the ethics side of it. Actually, most universities and schools, computer science, computer engineering programs, even though they're accredited, they say you have to have an ethics course. Majority of people that I would ask to say, hey, what was your ethics course like? Well, they'll probably say, well, it was, I don't remember what we talked about in there. Or they may say, well, we had an ethics week in one of my other classes. It wasn't a whole course, but it was a week, you know. And so I think, you know, other industries and other arts and other majors, law people as well as doctors, they have multiple courses in ethics, right? And that same thing should be applied to the computer science and computer industry. Even industries should be doing, we should be doing ethics trainings, we should be doing fairness and bias trainings, privacy trainings when we're developing. And remember, you would think that, you know, the industry is so much farther ahead than what it is, and we are not. We're just scratching the surface, peeling back the onion layers, and we're seeing more and more underneath. And so for us to get ahead as scientists, as engineers, we have to make that a priority.
Yes, I love the way you say that, and I'm about to jump to you because you know what I'm going to ask you about. Part of the work that I've been doing at Brookings is how do you develop these interdisciplinary models, right? When you're trying to actually deal with AI so that you could look at bias and these pre-assessments, or you look at the impact of bias. But Faye, at the end of the day, fairness and ethics are so elusive, right? And I was just having this conversation, Dr. Ray, when it came to looking at some of the legislation that is somewhat, they take it to a point, right? And then they pull back a little bit. Dr. Faye, help me understand, like, how do we look at something like facial recognition, which has unintended consequences, has the potential to over-criminalize, has the potential to surveil, has the potential to actually, you know, discriminate against people who are Black and brown based on the technological inefficiencies, as well as the lack of training or incentive to be ethical, potentially, right, on those products. How do we begin to sort of debunk fairness so that we can incorporate that into these new technologies like facial recognition?
Wow, that's a loaded question. I mean, it was so much said about my colleagues here, right? So I had to write down things so I could make sure that I get to these points. So I think one of the important things that we must do when we're talking about AI, fairness, there's ethics, there's accountability, and then there's transparency, right? So a sort of a FEAT model associated with AI and the models that transpire. What I mean by that, all of that said, we need a human into the loop. Technology must be paired with a human into the loop at each stage of that development, right? And so I think using computer scientists, engineers, sociologists, statisticians, political scientists, art majors, I'm going to even go so as far as to say, I think what happens inside of higher education when we look at it and why we run behind of that technology is because ethics may be taught, as our colleague has said, one course in the computer science or computer engineering curriculum, but in sociology and other disciplines, there may be multi-layers of an ethics course, but we all are working from a different definition. And I'll give you this example. So sitting in a school of business, everything is about the ROI, the return on the investment. Whereas in sociology, you're going to ask a different question. Whereas in computer science, that question may be, did you just understand the framework and we thought about it, but what does that mean? Secondly, I want to say that I think what is important, and Dr. Ray has mentioned, is sort of verifying these models, testing these algorithms. I call it an AI audit. Audit comes out of an accounting discipline. Just as we can audit a balance sheet or an income statement, there needs to be an AI audit process within organizations that must be adopted. The same people that actually create the model cannot be the people that test the model, cannot be the people that use the model. That's segregation of duties. That's fundamental. That must happen. And then lastly, I'd say, when we're talking about errors and testing for errors, errors have lived experience consequences, particularly for Black and Brown people. Now, the first question you gave me, Dr. Lee, was about a healthcare example. So, you know, and I'm sure all of us on the call have been to a physician. I had several false positives. What does that mean? Did that mean I burdened the system with other tests that I necessarily did not need? But if you think about the false negative, the reverse, and when Black and Brown people may not get services that they need, what are the downstream consequences of? And just to give you an example, and we've talked about this one before, when you think about difficult pregnancies in Black women, when you think about pain toleration, because Black and Brown people are expected to be more tolerant to pain. So certain medications or procedures may be withheld. So I think thinking about the fairness, the equity, the accountability, and the transparency, dovetail that with the ethics component. We must look at how can we audit and how can we then form these interdisciplinary teams to agree upon what are we talking about when we talk about ethics.
Yes, yes. And I love that you're talking about this because many people don't realize out of all the autonomous systems that we actually are engaging with, facial recognition is actually a small portion of it, right? It doesn't make up the broad base of AI systems. That's but right. it has one of those critical outcomes, Dr. Ray, in terms of the unintended consequences for particular communities. And I would love to talk a little bit about training data. Right? There's been lots of research that basically says based on the type of training data you use in facial recognition systems, you're going to get one result or the other. Georgetown University did a study not too long ago that said relying upon mugshots of African Americans, for example, in facial recognition only generates further criminalization of particular populations because that data set is flawed. Dr. Mark King, who was at a session that I was attending one time, said the same thing. I mean, talk to us about where the training data actually feeds into that. Because I would like, as Ashley said, some technology to recognize me when I change my hair. I would like that to be the case so that I'm not always trying to figure out which technology works better on me as an individual.
Well, look, I mean, to Dr. Kyle Payton's point, I mean, facial recognition and AI bias impacts everything. I mean, right now we're trying to figure out vaccines, and people who are part of the clinical trials, that's not representative of the US population or even the world population. It's going to have grave implications in terms of how we think about that. And so what goes into the algorithm matters a lot. That oftentimes scientists and techies are using, engineers are using a database of faces. And oftentimes these faces do not represent what people actually look like, nor does it include enough minorities to ensure that, as Dr. Kyle Payton was talking about, that it gets over the academic threshold of significance. And I think one big thing that has to happen is similar to publishing in academic journals, where we have to have our significance level at the 0.05 or 0.01 level. We need to definitely ensure that's the case when we're talking about people's lives, particularly when it comes to what law enforcement can do, what's used in healthcare, even what's used in corporate America to make assessments about who should get a home loan, where investments should be done. All of these sort of things play a role in what's going on. And so as these faces come into the algorithm, What it means is if you don't have a diverse range of faces, then your algorithm is going to be completely biased. I'll give a very specific example. As you know, we have a virtual reality decision-making lab. And as we have police officers come in to take that, part of what we have to ensure is that these officers are diverse by age, by experience, by race, by gender, by geography, by what role they play. Because if not, then the program will have biases related to that particular group and not to others. And that can have grave implications, particularly when in law enforcement, they start using these programs to train. So now, to your point, when they've put mugshots of Black people into an algorithm, now all of a sudden that's going to shape and further double down on the stereotypes that people have about Black people's bodies and whether or not we're prone to criminality or not. And so these have grave implications for some of the outcomes that we're talking about. And part of what needs to happen is we need to slow down. And some companies have done that, right? Like Amazon is a good example, leading the way in terms of saying, look, let's make sure we get this right. We can rush it through because the regulation isn't there from the policy side, but that doesn't mean we should do it. Instead, we should get it right to ensure that everyone is equitable. And I'll make one more final point on this, is that when you look at Americans' views on this, it's pretty interesting to look at how people think about facial recognition technology. So people oftentimes don't seem to have a problem with trusting police's use of force with facial recognition. And in fact, about 70% of Americans believe that facial recognition properly identifies people. And I think that's one of the fundamental problems, is that people trust the technology because they think that it's not biased. But of course, similar to everything else, that Black people and young people have different views of these technologies because they experience technology differently. They have a more nuanced perception of what's going on. So what that means is that while about 60% of white people actually think that facial recognition should be used in law enforcement, less than 40% of Black people do. And I think it's because we recognize the ways that these technologies can be used to further disenfranchise, marginalize, and discriminate against us.
No, I mean, I think that is a great point that you're making, because I think that's why we are continuing having these conversations around facial recognition technologies. And we have to figure out, to your point, what is the general satisfaction or comfort level with people's use of it, but then also where are those guardrails that we actually have to pay attention to. Now, Nancy, I have a question for you, but before I do that, I want to make sure that the audience that is watching, that you put your questions in the chat. We are taking questions. I want to thank the few of you that are actually out there tweeting this great conversation, very insightful, at TPRC Tweets, and use the hashtag facial recognition, but please add questions to the chat. Nashlie, when you think about the work that you do in particular, and I love the way that you've actually talked about, having people who have an authentic experience as a scientist to what we might be studying, having people at the table who may be interdisciplinary is important. What do you think in terms of just companies overall that they need to do to pay attention to what may be sort of this mismatch between what the technology does, right, and what it may do going forward? How do we keep that dialogue going?
Yeah, so the dialogue within the companies.
Yeah.
So I think like I mentioned, we have to get beyond this thought that biases and fairness is not an issue, not a concern, or that the issues do not exist. Once we get beyond that and we understand that we don't know that they don't exist until we know. We don't know until we know. And so then it becomes a matter of, okay, how do we prioritize what's most important to really look into for the products that have already been deployed. Now, for the products that are upcoming, again, all the stakeholders involved have to come to the table and say, okay, we need to think about these initiatives up front. This needs to be a part of the design process for developing this software or this product. I think also in the products that have already been deployed, there needs to be a conversation between the product lead as well as the person who's doing the testing and the measuring. Like Dr. Kyle Payton says, it's a conflict of interest to put all the burden on that one team to say, okay, you all let us know when you're ready. Let us know when it's fair and biased, so we'll know when to release the product. It's not going to work like that. Half the time, even just in software development in general, it's never a good idea for the developer to test their own software. because you're gonna miss bugs and miss little things because you've been looking at it, you've been in the trenches working on it, and so you're thinking, you know, everything's okay. And so that's why we have these testing teams. That's why you have test engineers. That's why you have UX designers to go back and look through these type of things and user studies. And so the same way that we check for security, we need to have a conversation. Now, sometimes there will be a little, and hopefully, fortunately, hopefully there will be friction between the product leaders and then the people doing the testing, because you want that dialogue to make sure that they're actually thinking about everything fully and discussing it and arguing over it. Like, I want you to argue over it because I want everybody to see the other person's viewpoint and understand it fully so that we can know the best way to move forward. Even as my team, as someone who goes out and does benchmarking and testing for all of our AI services, I still want to understand, who are your customers? Why is it less than, we can't do everything in a day. That's why I get back to prioritizing. I need to understand from you as the product lead and the product owner, okay, who are your top customers? Who are the most amount of people that this is going to affect? What are the revenue streams? And have you already deployed something? If we do need to stop this particular product, how is that going to affect you downstream? Let's talk about it. Let's put everything on the table and let's understand, you know, where we need to go. And then it needs to be the upper level management top down mandate to say, okay, the final straw is we will make this a priority. It shouldn't be up to the product lead, because they're going to say, 9 times out of 10, they're going to say, oh no, we're going to put this as a lower priority and we're going to go ahead and deploy because we need to start generating revenue. But, you know, and it may, and in some cases, biases are okay. Some use cases, biases are perfectly fine depending on what the use case is. If you're developing a product to help specialize recognizing voices or recognizing faces in a small village in Nigeria, and everybody has darker skin, then yes, I want my algorithm to be biased towards that group, that individual, those group of individuals. If I'm creating this, which I think is not a bad idea, I think, and this is just me talking overall, what you'll start to see is where we were trying to scale and create one solution that fits all, you're going to start to see variation and nuances in between each group so that we can serve a greater population. And you'll start to see algorithms totally take a turn on how we're developing them and how we're publishing papers, and really take these fine tooth and refine how well we're doing for this one group and this one group. And what you'll find is that that's going to affect and have a greater representation for all the other groups as well.
Yeah.
And then keeping it. Oh, go ahead.
Go ahead, Ashley. No, go ahead. I was gonna ask you though, and maybe turn it over to Faye so she could jump in. Part of this has a lot to do with the optimization of the algorithm, right? And the performance that we find a lot of developers trying to optimize, at least say, okay, well, if it doesn't perform well in this scenario, then where will it perform well? Which is what I hear a lot from engineers. The question I have though, and I want to throw it to you, Faye, is, but how do we ensure that if it's not performing well, particularly facial recognition among certain populations, that we need to do a better job making sure it does, right? And we need to maybe populate it with more faces. I mean, have we ever considered, and I'm gonna throw it out to the scientists and the sociologists, and then I'm glad, keep bringing the questions. I've seen the questions come through, and in a moment I'm gonna shift to that. How do we ensure that we can get better data sets? Do we need to ask Black women or women in general if we're doing pain threshold algorithms, or we're doing better facial recognition, Rayshawn? Like, do we need to ask them, can we take your face? Because there have been plenty of incidents of companies, not Ashley's, where they've taken photos of people without them knowing and then put them in a database.
Well, what a novel thought, right? As a sociologist, you can appreciate user participatory design and community participation, right? You would never do a study and not ask me for my consent, right? So I think part of that issue is, and I stand by this, there is so much focus on big data, and how we can garner that big data electronically, either knowing or unknowingly, to the target population. What we have ignored, Dr. Lee, is small data. That means hearing your voice, asking your community, understanding the social determinants of health, wealth, education, and the like. those are really critical when it comes to Black and brown people. You ask about that, and part of that issue is the training problem, right? And so if you're asking for if someone should be trained, if the data should be trained, but we all know that Black and brown people are less likely to participate, then perhaps we need to engage. There are experts here on this call and many other places that have the expertise. Why not engage with those experts? I think the other thing is we need to rethink how we are designing and probably move to more what we've called, and my colleague and I published a paper on this when we were looking at hiring biases in AI algorithms. And we sort of adopted this model of a justice design, right? A design justice approach to AI algorithms. And in that approach, we recognize that bias doesn't have a one size that fits all, right? So bias can come in many terms. And we've talked about them today. We just didn't call them out. We did talk about data set bias. Then there's the confirmation bias. Then there's the interaction bias. And then, there is actually the automation bias. And that's where I think Black and brown really get caught up, because there are assumptions that the algorithm makes just by association. And that model may not fit. Therefore, we need to understand the small data, and we also need to understand the human into the loop and when to keep that human in that loop. And I could go, I could go on about testing errors and comparative models and what kind of confidence intervals, like Dr. Ray had mentioned, and Dr. Nashley here, but I'll turn it over to you. There's a lot that could be said.
No, I mean, that's why I love this stuff. I mean, I'm not a scientist, and I can go on about structure and, the impact of X, Y, and Z. And I love the fact that this conversation is interdisciplinary. We got a lot of questions too, so I also want to get to some of those questions. But Dr. Ray, I want to give you an opportunity to sort of chime in for just a moment on what Dr. Kyle Payton has talked about.
Oh, I'm taking notes over here. So, I mean, Dr. Kyle Payton and Nashley, I mean, they are going off. So I think about it like this, and this has been said, I want to double down on it, is how will the community be informed? Like, consent is something that has to be given. People have to agree to it. And oftentimes with our bodies and our faces, particularly for Black people and marginalized groups, it's just taken from us. It's never anything that we actually consent to. And we're seeing that right now with COVID-19 vaccine trials. Like, the reason why that scientists and NIH and companies are having a difficult time getting Black people is because when has the United States of America ever told Black people that we should trust the government or science or medicine when trying to collect information on us? And even those of us who are in these spaces, that's something that we struggle with. And so I think about it, that there is a real collective memory around what happens to Black people, to Latino people, to indigenous groups, to LGBTQ communities when we participate in these sort of things. We know that Black women are more likely to die when they're having babies. So why would they want to go to a hospital? We see a lot of people deferring outside of the healthcare model to be at home with the midwife. We also know that that when it comes to technology, what I think needs to happen is that the policy needs to require that it's mandated that consent is given, and then companies, law enforcement, healthcare agencies need to figure out how to get us to trust. That trust has to be gained. There's a broader narrative that just exists when we talk about these particular things. Like, well, I don't understand why they wouldn't want to participate. Instead, the question should be is, why would they want to? Why would they want to? And so what needs to happen is that tech companies, and Nashley said this best, and, I know we're going to hopefully get to this in a second. Of course, Brookings, what we're trying to do is what we're going to do is we're putting together a working group of these people, and Ashley laid it out very well, of who should be at the table. Like, these debates should happen. This is how good things come out of it. It'll be frustration. It'll be a lot of things, but it will be better for people who are going to be using this stuff. So when the policy is in place, then trust has to be gained by the people who previously did not have the right to that trust. And part of what is happening with technology is technology allows for, whether that's law enforcement, healthcare agencies, corporations, real estate developers, banks, it allows them to circumvent trust and just simply take the information. which is just going to continue to highlight the disparities that we see currently.
Yeah, I mean, I think that this, look, I needed more than an hour for this, folks. I think this is why it's so important. And again, thank you for joining in. TPRC is doing these webinars to take on these hard issues and topics leading up to our conference in February. So I cannot say enough that these conversations will continue in person in our February conference, fingers crossed. But
there's a lot to be said. There's a lot to be said.
I know there's too much to be said, but I want to get to some questions because I see some really good questions coming through the chat if you all don't mind. I'm going to start with my colleague and my fellow board member, Bill Dutton, who has asked a couple of questions, but I want to take it back to this law enforcement piece. And Dr. Ray, you probably are the best to answer this. His question is, accuracy has been a central issue in the application of computing to law enforcement since the 70s. Is it just a matter of time before the technologies are refined to a level that they can be trusted, or is there just a more fundamental flaw?
Yeah, great question. I think it's a broader fundamental flaw. The fundamental flaw, particularly in law enforcement, is that they've never been held accountable for what they use and what they do. And I think we don't have to look anywhere other than yesterday to what happened with Breonna Taylor. That when you start looking at something like no-knock warrants, technology plays a role in that, because some of the more advanced police departments are using an algorithm as it relates to hotspot policing to determine which areas they should focus on. And then no-knock warrants are more likely to be given in those areas. Those areas are oftentimes predominantly Black neighborhoods or even Black households in predominantly white neighborhoods. But some people say, well, isn't that justified and warranted? No, because most no-knock warrants are given because of drug crimes. There really aren't racial differences in who uses drugs and who sells drugs, but there are huge racial differences in who's arrested, convicted, and incarcerated for drugs. And we know that Black people are oftentimes on the worst end of that continuum. So the accountability part in law enforcement is the problem, is that the reason why law enforcement uses this technology, like what's happening in Tampa, like what's happening in San Diego, is because they can. It's because they realize that when they use it, and they use it wrong, and they either shoot into someone's home and get charged with wanton endangerment, which is reckless endangerment for other areas, or shoot and kill someone, like what happened to Breonna Taylor, that there will be a lack of accountability, not only criminally, but also civilly, that they aren't held liable. Instead, taxpayers are on the hook for that. So not only are taxpayers paying for the technology that they didn't consent to be used on them, they are also paying for the civilian payouts when something goes wrong. And so it's not necessarily a lack of will. It's literally that they aren't held accountable and they never had to do it. And that's why this moment that we're living in right now, this social movement, is so pivotal, because for the first time, things are shifting with law enforcement, and it's very uncomfortable to them, and it should be, because oftentimes when people have been privileged, equality oftentimes feels like marginalization. And that's part of what's happening to them in this moment.
Wow. And I think it's so interesting. And based on Bill's question, I think the thing that you're sort of getting at is that until we change the fundamentals of law enforcement, right, we should not be introducing these new tools until we know they'll be equitably diffused. Nash, I want to go to you on this question around audits. And Dr. Baycott Payton actually brought it up, but I have another question for her. Much of AI is opaque in how it arrives at answers and conclusions. It's from Judson Carey. What is the latest research in AI audit technology that would reveal bias and errors in the AI process?
So that area of research is called explainable AI or interpretable AI. And unfortunately, it's just, again, we're just scratching the surface of what that means and what that is capable of doing. Back when technologies like algorithms were first developed and first used in these type of scenarios, there wasn't any big data machine learning. Everything was done by if this happens, then do this. If this happens, then do that. And it was all like written down in a list. And that's how algorithms worked. And it was really simple, it was straightforward. You can clearly see what was going on because, you know, it's explicitly stated. However, it wasn't very effective. It wasn't very accurate. It didn't really work well on a larger scale. And so then the introduction of machine learning came to the table, what we now call AI. And so that's looking at lots and lots of data, algorithms that comb through all this data to find these patterns. And now that I've recognized these patterns, I can go out into the wild and recognize things that look just like the patterns that I saw. And so when this was introduced, the algorithms became so complex. And instead of using X, Y, Z, we're now using, instead of 3 parameters, we're now using 100 million parameters. And we're now not even able to visualize what that algorithm or what that line or what that parabola even looks like. And so we call these neural networks. And so it is very difficult, even for the person developing and training the algorithm, to understand, let alone me trying to communicate that to someone who isn't in this space. And so now we're coming across where if we're going to hold people accountable, then if you come to me and you say, hey, your algorithm did X, all this stuff in X, Y, and Z, and I say, oh, well, I didn't know that it was going to do that. I can't show that to you. That's not going to fly, right? We're getting to the place where that's not going to be something that, we want to let companies get away with, in other words. And so we have to develop the technology to explain the technology. It makes no sense, but this is where we are. And so I think you'll start to see a lot more progress and things coming up. Like I said, if you were to look, for example, if you were to go on Google, explainable AI algorithms or interpretable AI, you'll see a lot of the recent publications and papers come up, but we're still kind of in a very primitive state there.
Yeah, I love that. I mean, I think we have more to do, right? And I think we have more to do based on this conversation of putting in some more interdisciplinary models to sort of enhance the current explainability models that we're actually seeing in processes coming out of science. Okay, I have another question. This is from Sapita Karimi, who was asking this question, which is actually another question that was asked in Faye. I'll throw it to you, and then anybody else can jump in this. So Sapita says, in my opinion, the inherent racial biases in facial recognition technology seem like a temporary problem. It is only inevitable for this technology to improve its accuracy rates as it scrapes open source data, for example, and therefore becomes an extremely effective tool for 24/7 surveillance. In light of this potential, do you think that FRT should be banned entirely? If not, what restrictions do you think need to be placed on its use? And that's probably the last question, everybody, so I try to combine a couple, but why don't you end there and then I'll close us out.
Well, I think the idea of this is a temporary problem, I guess we asked the people that were part of that 7% that had medical errors wrong and did not survive. I think in the context for which we're talking about, this impacts the lived experience. When the open heart surgeon, there was actually a case I clearly remember. The open heart surgeon was to do surgery on a 12-year-old, and there was a mismatch on the blood type. What happened? I mean, we wouldn't want to tell her parents this was a temporary problem, right? And so I think the degree to which this impacts lives, we can no longer say that it's a temporary problem because the horse is out of the cart, or the train is out of the station, whatever that little, symbolism is that we use. So do we think that it should be banned entirely? I don't know that it's entirety. I think the applications need to be really safeguarded and take into account a number of the issues that we have talked about with this regard in this context. And so I don't know of totally abandoning these, but I do think in some cases where Dr. Ray is talking about policing and military policing and those, we might want to do that. And so I think it depends on the application itself and the degree to which there is a likelihood that a false negative or a false positive, and not just enough to know that it's false in either case, but to know downstream what are the implications for the persons that are in those scenarios.
Right. Dr. Ray, you want to jump in on this ban idea? I mean, we've had conversations about it, and I would love to chime in myself, but I'm deferring to you three today.
No, I think you should. I mean, I agree with everything that Dr. Kyle Payton said. I mean, I think the bottom line is this. So the baseline of the question is, where it seems like eventually, I mean, we could get to where this facial recognition isn't biased. Sure. And we've had tons of years to do that. And guess what? We haven't done it yet. You know why? Because not only hasn't there been any political will to do it around kind of understanding wanting to do it, but we also have to be very realistic that the group that the biases play out on are oftentimes the groups that people care less about. So people oftentimes care less about the biases playing out. If the biases went in a different direction, I'm pretty sure they would be correct by now. And I think that's part of the fundamental thing, is that the policy has to come into place so that these sort of guardrails are put in place. And this is the thing, right now we're behind the 8 ball. Things actually need to not only slow down, but reverse in a sense, almost start over, to ensure that the biases are not embedded in the algorithms. Because no matter what, if the well is already poisoned, no matter how much bleach or good stuff you put in it, there's going to still be poison in there. And I think that is the point of how we think about facial recognition and AI bias.
Yeah, I mean, in my research, I always start out when I talk about AI bias, and for those of you who know me, this is an area that is near and dear to my heart because of the structural alignment I believe that happens in science, that at the end of the day, and I think Nashley sort of spoke to this, that the values, assumptions, and norms of individuals actually factors into the model's development. Does not necessarily suggest that the model is explicitly biased from the start, because you may have a certain set of assumptions. But what it does mean that our unconscious bias and our conscious will actually gets into these models in ways that affects its outcome. And then if we know algorithms and the way that they operate, we also know that once it's deployed, that they pick up on all the other junk that is around us. What people have searched for, their affinities, their likes, how polarized, how inclusive. And at the end of the day, it actually creates something that may have started as an input in the black box, but becomes something else. And so having these conversations in areas like criminal justice with facial recognition technology, like healthcare, like employment, like education, where at the end of the day, we would hope that it would inevitably resolve itself. It cannot, because in many respects, computers don't bias, we as people do. And the context in which they're deployed, these models are deployed, very much represent us. And that leads me to this final question that maybe I may not even be able to get a word from any of you on this because we are running out of time. But I do love this from an anonymous attendee who said this: are we optimistic that AI will ever be sufficiently free of bias? Janelle Shane argues in her book that AIs always develop biases, some of them bizarre, but potentially consequential. And I think that's actually a good way to end this conversation. At the end of the day, we probably will never be sufficiently free of bias. And we may also need to carefully think about how we get ahead of the technology, oftentimes through bans, without realizing that, I think everyone sort of said this, that maybe we need to do the hard work and roll up our sleeves to figure out how to diffuse equitable, fair, and responsible AI that also includes some stronger definitions around fairness and ethics, or at least measurements and tools for us to measure whether or not we're doing a good job there. I cannot thank you all enough. I don't know if anybody has a 20-second, 10-second, 2-second comment to say back at me before I close this out.
It was
good.
great.
Because we're about to end, and I don't want to be the person that goes last. Thank you, everybody, for chiming in. I want to again say to folks that are out there who are either new to TPRC, or this is the first time that you actually logged onto a webinar that a friend shared, come to the conference, get engaged with the community. At TPR Tweets is how you actually stay involved with this discussion and others. We are hosting a series of these webinars and more to come. The next one is going to be on misinformation and disinformation in elections, followed by one on digital divide, followed by one on privacy. Thank you again, and I appreciate all of you for participating today, both on this panel and giving us an hour of your time today. So we'll wait just a moment to log out, but thank you.